A satellite built to measure photosynthesis from orbit just received its final fuel load ahead of a September launch. This is Fascinating Frontiers, episode 167. Europe's newest eye on the health of Earth's vegetation has taken another crucial step towards orbit. The European Space Agency's FLEX satellite has been fueled at Europe's spaceport in French Guiana. The spacecraft will measure fluorescence from vegetation to track plant health and photosynthetic activity across Earth. Launch is set for 15 September at 3:21 a.m. Central European Summertime, which corresponds to 14 September at 10:21 p.m. local time. FLEX carries a single instrument designed to detect faint light emitted by plants during photosynthesis. Engineers will now complete final checks before the satellite moves to the launch pad. The mission will operate in low Earth orbit and deliver daily global maps of vegetation stress. Now, on a completely different note, NASA has confirmed that the Link spacecraft will not boost the Neil Gehrels Swift Observatory to a higher orbit. An ongoing attitude control issue on the commercial vehicle prevented the planned capture and reboost. The observatory will remain in its current orbit and is expected to re-enter the atmosphere later this year. Swift has provided ultraviolet and X-ray observations of gamma-ray bursts and other transients since 2004. No alternative reboost option is currently available. The decision follows an extended period during which teams assessed whether the commercial spacecraft could still complete its task. Swift has operated for more than 2 decades, delivering rapid ultraviolet and X-ray follow-up of cosmic explosions. Its loss will remove one of the few instruments capable of immediate multi-wavelength observations of transient events. The Nancy Grace Roman Space Telescope will observe from near-infrared into some visible wavelengths. Hubble covers near-infrared through ultraviolet, while Webb spans near-infrared to mid-infrared. Each instrument therefore captures distinct features of the same cosmic targets. Roman's wide-field near-infrared camera is optimized for large-scale surveys of galaxies and exoplanets. The differences in wavelength coverage allow complementary datasets when all 3 telescopes study overlapping sky regions. Mission planners note that the combination of perspectives strengthens studies of cosmic evolution and exoplanet atmospheres. An iceberg originating from northeastern Greenland traveled more than 1,000 kilometers south during summer 2026. The drift path took the berg through the Denmark Strait between Greenland and Iceland. NASA Earth Observatory imagery tracked the iceberg's movement and melt. Such long-distance drifts are uncommon for icebergs from that source region. The observations help refine models of iceberg trajectories and their impact on ocean circulation. Researchers continue to monitor how these events influence local salinity and marine ecosystems. Engineers are examining radioisotope power systems to supply heat and electricity during the 2-week lunar night. Surface temperatures drop below -180 degrees Celsius, halting most solar-powered operations. Nuclear sources would allow landers and rovers to continue working through the darkness. The approach builds on systems already used on Mars rovers and outer planet probes. Development focuses on compact, lightweight units suitable for crewed and robotic missions. The technology could extend surface operations at the lunar South Pole, where sunlight is limited for extended periods. The spacecraft is approaching the milestone distance light travels in a single day. That distance equals roughly 26 billion kilometers. Voyager 1 has been traveling outward since 1977 and currently moves at about 17 kilometers per second relative to the Sun. Mission teams use the benchmark to illustrate the scale of interstellar space. No other human-made object has reached this range. The milestone underscores how far the probe has traveled while still returning data from beyond the heliopause. 1 light day equals the distance light covers in 24 hours, roughly 26 billion kilometers, or about 650 times the average Earth-Moon distance. Imagine riding alongside a photon as it leaves Earth. In 1 second, it has already passed the Moon. In 8 minutes, it reaches the Sun. Yet a full day later, it is still only a tiny fraction of the way to the nearest star. Voyager 1, now traveling at 17 kilometers per second, will need another 20,000 years to cover that same interval at its current speed. The milestone therefore marks not just distance, but the immense gulf between our fastest spacecraft and the rest of the galaxy. We can calculate the number precisely. Yet we still do not know how the solar wind and interstellar medium interact across that final stretch of Voyager's journey. The companies signed a Memorandum of Understanding on 19th August, giving IN2 access to Eartheye's multi-sensor satellite tasking. IN2 will use the data for consulting projects that require Earth observation imagery and analysis. The agreement expands commercial use of Eartheye's constellation without requiring new satellite hardware. Both organizations expect the partnership to support clients needing rapid tasking and derived products from multiple sensors. NASA researchers modeled conditions in permanently shadowed craters near the lunar South Pole. Some terrestrial microbes could remain viable in these cold, dark niches if carried by future landers. The study highlights the need for planetary protection measures during crewed exploration. Survival would depend on protection from radiation and extreme temperature swings. The findings inform ongoing discussions about contamination risks at potential Artemis landing sites. LandSpace's Zhuke 3 rocket completed a controlled landing using landing legs on 19th August. The flight marks the first time a Chinese commercial firm has returned an Orbital-class booster. The vehicle touched down after delivering its payload, demonstrating reusability technology. The successful recovery represents a milestone for China's emerging private launch sector. A SETI Institute team is developing the interworld slingshot concept to identify surface materials from orbit. The technique would use targeted impacts or gas releases to loft dust for spectroscopic analysis. The approach avoids the cost and complexity of drilling or sample return. Early modeling focuses on the Moon and near-Earth asteroids. Lead researcher Pablo Sobran and colleagues are refining the method to work with existing orbital platforms. New Horizons images show evidence that liquid nitrogen is moving upward along fractures in Sputnik Planitia. The process could explain dark streaks and surface wetting observed along the northern edge of the heart-shaped plane. The finding adds to understanding of Pluto's ongoing geological activity driven by subsurface heat. Data from the 2015 flyby continue to yield new insights into the dwarf planet's interior dynamics. A pen-sized device fires plasma to kill microbes on fabrics without water or detergents. The technology targets odor-causing bacteria that accumulate during long missions. Laboratory tests showed effective sterilization on common spaceflight textiles. The tool could reduce the mass of clothing carried on future deep space flights. Developers are now evaluating integration pathways for use aboard the International Space Station and future exploration vehicles. New instruments and missions keep revealing how little we still know about the systems closest to home and farthest away. Before we go, keep an eye on the next steps for the swift follow-up observations that astronomers will need to prioritize. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. Quick tip from the network. Try Planetarian Daily next. Daily breakthroughs in science, health, and longevity. Every NERA Network show is free at neranetwork.com. Following the long arcs, story trackers on neranetwork.com follow major programs across episodes: Tesla, SpaceX, AI, space science, and more. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through